Yes, next numerical based on electric charge and fields. 2 point charges 3 nanocoulomb and minus 3 nanocoulomb are placed at the corners of A and B of an equilateral triangle ABC of side 0.3 meter in air. I repeat, 2 point charges 3 nanocoulomb and minus 3 nanocoulomb are placed at the corners of A and B. Here it is the corner A of an equilateral triangle. The charge will be 3 into 10 raised to the power minus 9 coulomb and minus 3 nanocoulomb is at the point B. Therefore, in the point B, 3 into 10 raised to the power minus 3 into 10 raised to the power minus 9 coulomb are placed at the corners of A and B of an equilateral triangle ABC of side 0.3 meter in air. ABC of side 0.3 meter. The sides they are given 0.3 meter. If a charge of plus 2 nanocoulomb is placed at C, this point is considered as a C. The C in which we are placed by the charge is known as 2 into 10 raised to the power minus 9 coulomb. If a charge of plus 2 nanocoulomb is placed at C, what is the force acting on it? ಕೊಟ್ಟ ಕಂಡೀಷನ್ಸ್ ಏನಿದೆ ಇಲ್ಲಿ ಕೊಟ್ಟ ಕಂಡೀಷನ್ಸ್ ಏನಿದೆ ಅಥವಾ ಕ್ವಶನ್ಸ್ ಏನಿದೆ ಡಯಾಗ್ರಾಮಲ್ಲಿ ಬರೆದಿದ್ದೇನೆ. ದ ಟೂ ಚಾರ್ಜಸ್ 3 into 10 raised to the power minus 9 as well as minus 3 into 10 raised to the power minus 9 that are placed at the two corners of the equilateral triangle that is known as A and B, in which the third charge is introducing at the point is known as C, with the charge is known as 2 into 10 raised to the power minus 9 coulomb. What is the force acting on it? ಆದರೆ ಎಷ್ಟು ಫೋರ್ಸ್ ಕ್ರಿಯೇಟ್ ಆಗಿದೆ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಎ ವಿಚ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಚಾರ್ಜ್ ಆಫ್ 3 into 10 raised to the power minus 9, the C in which there is a charge of 2 into 10 raised to the power minus 9, hence there is a force of repulsion. That force is expressed by force on C is due to A is given by FCA or FCA vectors, as well as 2 nanocoulomb 2 into 10 raised to the power minus 9 coulomb as well as minus 3 into 10 raised to the power minus 9 coulomb. Minus 3 into 10 raised to the power minus 9 coulomb. There is a force of attraction between these two charges. First condition ಹೇಗಿದೆ ಕೇಳಿದರೆ A ಅನ್ನುವಂಥ ಚಾರ್ಜ್ ಎಷ್ಟಿದೆ ಕೇಳಿದರೆ 3 into 10 raised to the power minus 9. C ಯ ಚಾರ್ಜ್ ಏನಿದೆ ಕೇಳಿದರೆ 2 into 10 raised to the power minus 9. There is a force of repulsion between these two charges. ಯಾಕೆ ಕೇಳಿದರೆ ಎರಡು ಸಹ ಒಂದೇ ರೀತಿ ಇರುವಂಥ ಚಾರ್ಜಸ್, ದಟ್ ಇಸ್ ದ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್. ಹಾಗಾಗಿ ಹೇಗೆ ಬರೆದಿದ್ದಾನೆ ಕೇಳಿದರೆ ಫೋರ್ಸ್ ಆನ್ C is due to A is given by FCA vector or FCA, as well as in the second condition the charge on B is minus 3 into 10 raised to the power minus 9, the charge on C is 2 into 10 raised to the power minus 9 coulomb. Here it is the charge is known as a negative, here it is the charge is known as a positive. There is a force of attraction between these two charges, therefore that is expressed as FBC. Since force on C, force of attraction on C is due to B, therefore FCB. Therefore we have to calculate the resultant force, that is known as an AF. For a parallel angle, equilateral triangle ಪ್ರತಿಯೊಂದು ಆ್ಯಂಗಲ್ ಏನಾಗ್ತದೆ ಕೇಳಿದರೆ 60 ಡಿಗ್ರಿ. ಹಾಗಾದರೆ ಅದರ ಪ್ಯಾರಲಲ್ ಆ್ಯಂಗಲ್ ಏನಾಗ್ತದೆ ಕೇಳಿದರೆ ದ ಆ್ಯಂಗಲ್ ವಿಲ್ ಬಿ 120 ಡಿಗ್ರಿ. ಫಾರ್ ದ್ಯಾಟ್ ವಿ ಆರ್ ಯೂಸ್ ಬೈ ದ ರಿಲೇಷನ್, ದ ಫಸ್ಟ್ ಒನ್ FCA is equal to force on C is due to the charge A. There is a repulsive force that is expressed by according to the Coulomb's law. F is equal to 1 by 4 pi epsilon naught Q1 Q2. In the place of Q1 we are written by QA. In the place of Q2 we are written by QC, as well as the distance from the point C to A is expressed by AC square. That is nothing but 9 into 10 raised to the power 9. That is the value of 1 by 4 pi epsilon naught. The value of QA will be 3 into 10 raised to the power minus 9 into the value of QC will be 2 into 10 raised to the power minus 9 divided by CA. In general ನಾವು Coulomb's law ಹೇಗೆ ಬರೆದಿದೆ ಕೇಳಿದರೆ 1 by 4 pi epsilon naught Q1 Q2 divided by R square. R ಅನ್ನುವುದನ್ನು ಹೇಗೆ ತಗೊಳ್ತಿದ್ದೇನೆ ಕೇಳಿದರೆ it is the distance from the point is known as A to C. Therefore the distance from A to C is they are given, that will be 0.3 whole square. Therefore FCA is equal to 6 into 10 raised to the power minus 7. ಇದನ್ನು ನಿಮಗೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ ಈ ಆನ್ಸರ್ ಸಿಗ್ತದೆ. 6 into 10 raised to the power minus 7 Newton. The second one, force on B or the force on C is due to be FCB is equal to again the same relation 1 by 4 pi epsilon naught QB QC divided by the distance is from B to C square, that is equal to 1 by 4 pi epsilon naught will be 9 into 10 raised to the power 9. QB, the value of QB is in terms of a magnitude 3 into 10 raised to the power minus 9 into the value of C will be 2 into 10 raised to the power minus 9 divided by the value of R square, that is considered as a BC square, that will be again 0.3 square. Therefore FCB is also equal to 6 into 10 raised to the power minus 7 Newton. This is answer for FCA as well as FCB. They are asking the question, what is the force? The resultant force acting at the point C. Therefore the resultant force F is equal to, by the relation FCA square plus FCB square plus 2 times of FCA times of FCB times of cos theta. ರಿಸಲ್ಟನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡುವಂಥ ರಿಲೇಷನ್ ರಿಸಲ್ಟೆಂಟನ್ನು ಹಾಗಾದರೆ ಎಫ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ದ ರಿಲೇಷನ್ ಎಫ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎಫ್ ಸಿ ಎ ಸ್ಕ್ವೇರ್ ವಿಲ್ ಬಿ 6 into 10 raised to the power minus 7 square plus again 6 into 10 raised to the power minus 7 square plus 2 into 6 into 10 raised to the power minus 7 into 6 into 10 raised to the power minus 7 times of cos 120 degree, that is equal to, by substituting all these values we are getting as the answer will be 6 into 10 raised to the power minus 7 Newton is the answer. 5 more question. I repeat, ನೋಡಿ ಕೊಟ್ಟ condition ನೋಡಿ 2 point charges A ಮತ್ತು B ಅಲ್ಲಿ ಎರಡು ಚಾರ್ಜ್ ಕೊಟ್ಟಿದ್ದಾರೆ. The first charge is 3 into 10 raised to the power minus 9. The second charge will be 3 into 10 raised to the power minus 9. The point seen with the charge they are given will be 2 nanocoulomb, that is 2 into 10 raised to the power minus 9. Now the first condition, force on C is due to A. There is a repulsive force that is expressed by FCA. The second condition, the force on C is due to B. There is a force of attraction. Since the one charge will be negative and the charge C will be in a positive, there is a force of attraction. Therefore we are finding the values of FCA as well as the FCB. Here we are taken the magnitude. ನಿಮಗೆ ಇಲ್ಲಿ ಒಂದು ಡೌಟ್ ಬರ್ತದೆ, ಬಿ ಕೊಟ್ಟಿರುವಂಥದ್ದು ನೆಗೆಟಿವ್ ಅನ್ನುವಂಥದ್ದು. ಬಟ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಕುಲಮ್ಸ್ ಲಾನ ಪ್ರಕಾರ ನಾವು ಚಾರ್ಜನ್ನು ಹೇಗೆ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು ಕೇಳಿದರೆ, ಫೋರ್ಸನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡುವಾಗ ಇಟ್ ಇಸ್ ದ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ದ ಚಾರ್ಜ್. ಹಾಗಾಗಿ ಇಲ್ಲಿ ಏನು ತೊಗೊಂಡಿದ್ದೇನೆ ಕೇಳಿದರೆ ಪ್ಲಸ್ಸಲ್ಲೇ ಬರೆದಿದ್ದೇನೆ. 3 into 10 raised to the power minus 9 into the value of C will be 2 into 10 raised to the power minus 9. We get it as FCB is equal to 6 into 10 raised to the power minus 7 Newton. Then the resultant force at the point C is given by resultant relation. Already ನೀವು ಸ್ಟಡಿ ಮಾಡಿದ್ದೀರಿ. F is equal to root of FCA square plus FCB square plus 2 FCA FCB cos theta. Parallel angle, equilateral triangle ಆದ್ರಿಂದಾಗಿ parallel angle, ಈ total angle ಏನಾಗ್ತದೆ ಕೇಳಿದರೆ 120 degree. FCA value substitute ಮಾಡಿದ್ದೀರಿ, FCB value substitute ಮಾಡಿದ್ದೀರಿ. 2 times of FCA will be 6 into 10 raised to the power minus 7. CB will be 6 into 10 raised to the power minus 7. Theta will be 120 degree, therefore cos 120. Therefore we are getting as the answer 6 in terms of 6 into 10 raised to the power minus 7 Newton. ಉಡುಪಿ ಡಿಸ್ಟ್ರಿಕ್ಟ್ನ 2019ನ ಮಿಡ್ ಟರ್ಮ್ ಕ್ವಶನಲ್ಲಿ ಈ ಕ್ವಶನನ್ನು ಕೇಳಿದ್ದಾರೆ, ಮಿಡ್ ಟರ್ಮ್ನ ಪೇಪರಲ್ಲಿ 5 ಮಾರ್ಕ್ಸ್ಗೆ. ದ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ NCERT ಕ್ವಶನ್, ಒನ್ ಮೋರ್. 4 point charges. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ಗೆ ಬರ್ತಾ ಇದ್ದೇನೆ. 4 point charges, QA 2 microcoulomb, QB minus 5 microcoulomb, QC minus 2 microcoulomb, plus 2 microcoulomb, QD that will be minus 5 microcoulomb are located at the corners of a square of side 10 centimeter. What is the force on a charge 1 microcoulomb placed at the center of the square? ನೋಡಿ ಕ್ವಶನ್ ನೋಡಿ, 4 point charges QA will be 2 microcoulomb. ಹಾಗಾದರೆ ಇಲ್ಲಿ ಎಷ್ಟು ಬರಿಬೇಕು ಕೇಳಿದರೆ, ಪಾಯಿಂಟ್ A ಸ್ಕ್ವೇರ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೇನೆ. ದ ಚಾರ್ಜ್ ವಿಲ್ ಬಿ 2 microcoulomb, that is 2 into 10 raised to the power minus 6 coulomb. The charge on B is minus 5 into 10 raised to the power minus 6 coulomb. Then the charge on C is 2 into 10 raised to the power minus 6 coulomb. The charge on D is minus 5 into 10 raised to the power minus 6 coulomb are located at the corners of a square. ಈ ಎಲ್ಲ ಚಾರ್ಜಸನ್ನು ಕಾರ್ನರ್ ಆಫ್ ದ ಸ್ಕ್ವೇರ್ ಅಲ್ಲಿ ಇಟ್ಟಿದ್ದೀರಿ. ಆಫ್ ಸೈಡ್ ದೇ ಆರ್ ಗಿವನ್, ಈಚ್ ಸೈಡ್ ವಿಲ್ ಬಿ 10 centimeter means 0.1 meter. all the sides will be 0.1 meter. Now what is the force on a charge 1 microcoulomb is placed at the center of the square. ಈಗ ನಾನು ಇಲ್ಲಿ ಏನು ಮಾಡ್ತಾ ಇದ್ದೇನೆ ಕೇಳಿದರೆ 1 ಮೈಕ್ರೋಕೂಲಮ್ ಚಾರ್ಜನ್ನು ಇಟ್ಟಿದ್ದೇನೆ, ಹಾಗಾದರೆ ಇದರ ಮೇಲೆ ಫೋರ್ಸ್ ಏನಿರ್ತದೆ ಅನ್ನುವಂಥದ್ದು. Now force on a charge 1 microcoulomb is at the point O is due to the charge carrier is known as 2 into 10 raised to the power minus 6 coulomb between the 2 points, that is known as A as well as the C, are equal and opposite. Reason ಏನು ಕೇಳಿದರೆ at the point O only 1 microcoulomb ನ ಚಾರ್ಜ್ ಇದೆ. That 1 microcoulomb is repelled by 2 into 10 raised to the power minus 6 coulomb. ಹಾಗಾದರೆ ಏನಾಗ್ತದೆ ಕೇಳಿದರೆ there is a repulsion between the charge between 1 microcoulomb as well as 2 into 10 raised to the power minus 6 coulomb. Again there is a repulsion between 1 microcoulomb as well as 2 into 10 raised to the power minus 6 coulomb. Therefore the direction is equal and opposite. The net force on this point is because of these two charges is equal to 0. ಪುನಃ ರಿಪೀಟ್ ಮಾಡ್ತೇನೆ. The force on 1 microcoulomb charge, the force on 1 microcoulomb charge is due to 2 into 10 raised to the power minus 6 coulomb charge is between the point A and C are equal and opposite. 1 microcoulomb ಅಲ್ಲಿರುವಂಥ ಫೋರ್ಸ್ ಏನಿದೆ ಎರಡು ಚಾರ್ಜಿಂದಾಗಿ 2 into 10 raised to the power minus 6 between the 2 points, ಎರಡು ಪಾಯಿಂಟಲ್ಲಿರುವಂಥ ಚಾರ್ಜಿಂದಾಗಿ ಆ ಫೋರ್ಸ್ ಆಗಿದೆ ಕೇಳಿದರೆ ಈಕ್ವಲ್ ಆ್ಯಂಡ್ ಅಪೋಸಿಟ್. ಹಾಗಾಗಿ ನಾನು ಡೈರೆಕ್ಷನನ್ನು ಬರೆದಿದ್ದೇನೆ. ದರ್ ಇಸ್ ಎನ್ ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್, ದ ಫೋರ್ಸ್ ಆಫ್ ರಿಪಲ್ಷನ್ ಅಂತ ಕರಿತೇನೆ ನಾನು ಇದನ್ನು. ದಟ್ ಫೋರ್ಸ್ ಆಫ್ ರಿಪಲ್ಷನ್ ದರ್ ಇಸ್ ಈಕ್ವಲ್ ಆ್ಯಂಡ್ ಅಪೋಸಿಟ್. ಇನ್ ದ ಸೆಕೆಂಡ್ ಕಂಡೀಷನ್, ಫೋರ್ಸ್ ಆನ್ 1 microcoulomb charge, that force is known as an attractive force, since the reason is that 1 microcoulomb as well as a minus 5 microcoulomb, 1 microcoulomb as well as a minus 5 microcoulomb, there is a force of attraction. First conditionally 1 microcoulomb 2 microcoulomb, 1 microcoulomb 2 microcoulomb, there is a repulsive force. 1 microcoulomb minus 5 microcoulomb, 1 microcoulomb minus 5 microcoulomb, there is a force of attraction on 1 microcoulomb charge is due to minus 5 into 10 raised to the power minus 6 coulomb between B and D. Again the forces of attraction, these forces are equal and opposite. Therefore the answer is the net force on 1 microcoulomb charge is at O is 0 is the answer. ನೋಡಿ ಇಷ್ಟು ಆನ್ಸರ್ ಇರುವಂಥದ್ದು. ಬಟ್ ಇಲ್ಲಿ ಪಾಯಿಂಟ್ಸ್ ಇದೆ, NCERT ಫೋರ್ತ್ ಕ್ವಶನ್ಸ್, ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ಒನ್. 3 ಅಥವಾ 1 ಮಾರ್ಕ್ ಅಥವಾ 5 ಮಾರ್ಕ್ಸ್ ಸಹ ಕೇಳ್ಬೋದು. ಈ 5 ಮಾರ್ಕ್ಸ್ ಕೇಳಿದರೆ ನೀವು ಕನ್ಕ್ಲೂಷನ್ ಅನ್ನು ಕೊಡಬೇಕು. ಯಾಕೆ ನೆಟ್ ಫೋರ್ಸ್ ಆನ್ ದ ಚಾರ್ಜ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 0 ಅಂತ ಕ್ವಶನ್ಸ್ ಬಂದರೆ. ದ ರೀಸನ್ ಇಸ್ ದಟ್ ಹಿಯರ್ ಯು ಆರ್ ಟೇಕನ್ ಬೈ ದ ಚಾರ್ಜ್ ಇಸ್ ಕಾಲ್ಡ್ ಎಸ್ 2 into 10 raised to the power minus 6 at the point A. Here we are taken by the charge is known as 2 into 10 raised to the power minus 6. There is a repulsive force on 1 microcoulomb charge is because of the point A and C equal and opposite. As well as 1 microcoulomb charge, it experiences a force of attraction between the 2 points, or because of the 2 charges that are placed at the 2 points, that will be minus 5 into 10 raised to the power minus 6 as well as minus 5 into 10 raised to the power minus 6. The forces are equal and opposite. These forces are equal and opposite. Therefore the net force on 1 microcoulomb charge is at O is equal to 0. Is it clear? Question, 2 point charges 20 microcoulomb and minus 20 microcoulomb are placed at 20 millimeter apart. Calculate the electric field at a point on a axis of a dipole at the distance of 20 centimeter from the midpoint as a dipole. Question number B, on equatorial line as a dipole at the distance of 30 centimeter from a midpoint as a dipole. First question based on the electric field on an axial line. The second question, find out the electric field along the equatorial line. For that, axial and relation E axial is equal to, electric field along the axial is equal to 1 by 4 pi epsilon naught to 2p divided by r cube. In that 1 by 4 pi epsilon naught is common, but the value of P is known as a dipole moment. They are not given. In order to calculate that dipole moment, we are done by the relation P is equal to Q times of 2A, where Q is called as a magnitude of the charge. The charge they are given plus 20 microcoulomb and minus 20 microcoulomb. Therefore the magnitude of the charge will be 20 into 10 raised to the power minus 6 into 2A are placed at a distance of 20 millimeter apart. The value of 2A is equal to 20 millimeter, that will be 20 into 10 raised to the power minus 3. Therefore, the dipole moment we get it as P is equal to 1.60 into 10 raised to the power minus 7 coulomb meter. It's not centimeter, C capital, coulomb meter. Therefore, the value of dipole moment P is equal to 1.60 into 10 raised to the power minus 7 coulomb meter. Now, for the question number A, electric field along the axial line, for that 1 by 4 pi epsilon naught is expressed by 9 into 10 raised to the power 9, 2 times of P is called as a dipole moment, just we are calculated now, 1.60 into 10 raised to the power minus 7 divided by the value of R cube is equal to, question A itself they are given, on an axis at a dipole, as a dipole at a distance of 20 centimeter, it means that 0.2 whole cube. By substituting all these values, we are getting as E axial. We are substituting all the values, we are getting as E axial is equal to 3.6 into 10 raised to the power 5 Newton per coulomb. The electric field along the axial line is given by this value. The second one, for an equatorial line, on equatorial line as a dipole at the distance of 30 centimeter from midpoint as a dipole. Therefore, equatorial line relation, E equatorial is equal to 1 by 4 pi epsilon naught P divided by R cube, that is equal to 1 by 4 pi epsilon naught will be 9 into 10 raised to the power 9. The value of P will be in a dipole moment, that will be 1.60 into 10 raised to the power minus 7 divided by the value of R now. It's not 20 centimeter now. Question number A li kottaddu along the axial line ಗೆ 20 centimeter ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. But in the question number B, on an equatorial line, the distance is expressed by 30 centimeter. Therefore, the value of R is equal to 0.3 whole cube. By substituting that, electric field along the equatorial line is equal to 0.53 into 10 raised to the power 5 Newton per coulomb. Is it clear? The next question, the next one, a uniformly charged conducting sphere of a radius 1.2 meter R they are given, has a surface charge density of 80 into 10 raised to the power minus 6. This value will be the surface charge density of 80 into 10 raised to the power minus 6 C, that stands for coulomb, it's not centimeter, that stands for coulomb per meter square. Question number A, find the charge on the sphere. Question number B, what is the total electric flux leaving the surface? ಅದಕ್ಕೆ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಕೇಳಿದರೆ ಗಿವನ್ ಕ್ವಶನ್ಸ್ ಅಲ್ಲಿ ಯಾವ ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ ಕೇಳಿದರೆ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಆರ್ ಇಸ್ ಗಿವನ್ 1.2 ಮೀಟರ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ದೆನ್ ದ ಸರ್ಫೇಸ್ ಚಾರ್ಜ್ ಡೆನ್ಸಿಟಿ ಸಿಗ್ಮಾ ಇಸ್ ಗಿವನ್, ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಸಿಗ್ಮಾ ಇಸ್ ಈಕ್ವಲ್ ಟು 80 into 10 raised to the power minus 6 coulomb per meter square. Therefore, the surface charge density sigma is equal to charge per unit area. Sigma is equal to Q divided by A. In that we have to calculate the value of Q. Therefore, by rearranging the equation, Q is equal to sigma times of A. Sigma is surface charge density, they are given the value. A, area of the sphere is expressed by the general formula is known as 4 pi r square. By substituting the values in that sigma, that will be 80 into 10 raised to the power minus 6 into 4 into pi value will be 3.142. The value of R is given 1.2 whole square. By substituting this, the value of charge will be Q is equal to 1.45 into 10 raised to the power minus 3 coulomb. For the question number B, what is the total electric flux leaving the surface? According to the Gauss law, the electric flux that is expressed by pi E is equal to 1 by epsilon naught times the total charge enclosed by the system. Therefore, 1 by epsilon naught is expressed by, Q divided by epsilon naught is expressed by the value of Q will be 1.45 into 10 raised to the power minus 3 divided by the value of epsilon naught will be 8.85 into 10 raised to the power minus 12. Therefore, the value of pi electric flux is equal to 1.6 into 10 raised to the power 8 Newton meter square. I repeat, electric flux phi is equal to 1 by epsilon naught times of Q. The value of Q is just we are calculated, that value will be 1.45 into 10 raised to the power minus 3 divided by the value of epsilon naught will be 8.85 into 10 raised to the power minus 12, that is equal to 1.6 into 10 raised to the power 8 Newton meter square per C stands for a coulomb. This is the value of flux. Is it clear? The next question, ninth one, a infinite linear charge density, that is lambda, produces a field of 20 into 10 raised to the power 4 Newton per coulomb. A infinite linear charge density lambda produces a field of 20 into 10 raised to the power 4 Newton per coulomb. Electric field is given at the distance of 4 centimeter. The distance is given, that will be 4 centimeter. Now find the value of linear charge density. According to the concept of linear charge density, lambda is equal to Q divided by L in general, but we are calculating the electric in terms of the same relation we are calculated in terms of electric field due to an infinitely long straight conductor. E is equal to lambda divided by 2 pi epsilon naught r. Therefore, lambda is equal to E times of 2 pi epsilon naught r by rear in the equation. ನೋಡಿ ಇಲ್ಲಿ ಕ್ವಶನ್ಸ್ ಕೇಳಿದರೆ linear charge density in general lambda is equal to Q by L, but they are not given the charge in terms of electric field ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. That is the reason why we are taken by the derivation. Gauss law ನ first derivation ಏನಿದೆ, electric field due to infinitely long straight conductor ನ derivations ಏನಿದೆ, ಅಲ್ಲಿಂದ ರಿಲೇಷನ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದಾನೆ. What is the relation? E is equal to lambda divided by 2 pi epsilon naught times of r. Therefore, lambda is equal to lambda calculate ಮಾಡಬೇಕು. By rear in the equation, lambda is equal to 2 E times of 2 pi epsilon naught r. Electric field is given, the value of electric field E is equal to, question ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ 20 into 10 raised to the power 4 into 2 times of 3.142, that is the value of pi, epsilon naught, that is the constant value, 8.85 into 10 raised to the power minus 12 into the value of r, the distance they are given 4 centimeter. 4 centimeter will be, in terms of meter, it is expressed as 4 into 10 raised to the power minus 2. Therefore, lambda is equal to 4.5 into 10 raised to the power minus 7 coulomb per meter is the answer.